everyone, today we're going to be learning how to draw an exponential function, make the graph of it, and to define what an asymptote is and to find it. And we're going to be using our calculators. So I pulled mine up on the screen here. If you are at home and you do not have access to the calculator, what I want you to type in your computer is Desmos, and that will pull up a graphing calculator that you can use. Okay, so first, let's look at this. Reviewing something we've done before. What is the equation of this dotted line? Well, first let's think about what is the slope of this line. Well, that slope there it's perfectly flat, so it has a slope of 0. So when I do my equation, y equals mx plus b, my slope is 0, x, and then my b, which is my y-intercept right here, is 2. Well, when I multiply 0 times x, I'm just going to get 0. So y equals 2, because that right there made 0. So y equals 2 is the equation of that line. Another way that you can write it, because we're big boys and big girls now, and I'm going to refer to it this way for the rest of it, is f of x equals 2. Remember that f of x is just the function notation, and it means the same thing as y. Okay, what is the equation of this line? Well, if you've been in my class ever before, we call this the line of death. If you and your boyfriend or girlfriend walk on this line, I'm a really good artist right here, you will die, okay? It will be a tragic love story, so there we go. So this is called the line of death. It is x equals instead of y equals. The only lines that are x equals are the line of death. So 1, 2, 3, 4, 5. So it is x equals -5. Okay, this one right here, it's flat again. It's got that 0 slope, so I know it's going to 0 things out. So this one is going to be y equals, my y-intercept is 0. Okay, if you wrote it out beforehand, y equals 0x plus 0. Remember, this zeroes out. So my final thing that I'm going to write is f of x equals 0 because I like using f of x now. Okay, so now that we've done that, let's look at this. How do you graph an exponential function? Well, we're going to start with making a table of values. That's always a good place to start. So this is telling me I need to plug in -5 for x. So I'm going to come over to my calculator and I'm going to say 1 times 2 to the power of -5. Okay, and I'm just going to go ahead and type them all in, and then I can copy them off my screen. So 1 times 2 to the power of -3. Okay, some of you know the trick where you can just kind of go up and grab that and bring it down, and then you can just go over and change that to a 1. It just might make it a little bit quicker. I don't really know if it does, but it makes me feel like I'm doing less work, so I'm going to go with it. Okay, I'm going to delete my negative and put a 0 in there. Okay, I'm going to copy these before they go off the screen. So we have a 32. We have 32 is not right. I gotta check that. Oh, I've got a -5 in there. Okay, and I want to talk about why I knew it wasn't right. So I'm gonna plug these in here. Okay, and my screen is so small that I'm having a hard time seeing that. I guess I can make that bigger, but I could look at my pattern here and I say, hey, these numbers, you know, they're getting bigger this way, and I've got this random 32 in there, so I know that that's not wrong. So I'm going to bring this down, and I am going to go up there, and I can see that there's 2 negatives in there. I'm going to delete that, and there is my correct answer, okay? Hey, you know what? It's always okay to look at your answers and say, do they make sense? Don't just trust your calculator. Okay, so 0.3125, okay, and then I'm going to go up and get I'm going to get the one without the negative, because I can. And I'm going to change that 0 to a 1. And then I'm going to go ahead and get the other ones also, just because I can put them all on the screen at the same time. Okay, so there's my 2. And there is, I'm having a hard time here. Okay, there's my 3. Okay, so 2, 4, 8. Okay, so that tells me I can look at this and say, hey, I've got a pattern of timesing by 2. Okay, hey, look, there's my constant ratio. Hopefully you're noticing a few things that we've done before. Okay, so now I'm going to graph these ordered pairs. Let me get this off here because it does look a little messy. I'm going to start with the whole numbers because I'm better with whole numbers. Okay, so I'm going to start here because that's just seems like a good place. Okay, 0, 1. There it is. 1, 2. So over 1 up 2. Then I have 2, 4. Over 2 up 1, 2, 3, 4. And then over 3 up 8. 3, 1, 2, 3, 4, 5, 6, 7, 8. It will go off the graph, but that's okay. I can put that there. Now I'm going to do the negatives, okay? Negative 1.5, okay? It's right there. It's halfway in between. This one is going to be smaller than that, so negative 3. So right here, and then I just know it's not 0. And then negative 5 is also not 0. That dot looks a little bit close to 0, so I'm going to try to move it up a little bit. Okay, so what is happening on my graph here? I'm going to change this one because it moved up with the other one, but it does that. If we were to plug in negative 10, let's go ahead and do that for a moment. Okay, so I am going to bring that down, and instead of putting a 3 up there, I'm going to put negative 10. What happens to my number? Well, if you remember, that's scientific notation. What that is saying is I got 9.76. I'm going to stop there, and it's 1, 2, 3, 4. So my number is 0.00097. It would round to 7. I'll just go ahead and change it there to 977. But it's really close to 0. But is it 0? No. So I want you to think about our pattern here. We're timesing by 2. So what's happening when I go backwards? Well, I'm dividing by 2. Can you ever divide by 2 and get 0 if you're not starting with 0? No. It will never, ever, ever get to 0. Get smaller and smaller and smaller and smaller and smaller. Think of this. I have a cookie. I give half of it to my friend. Okay, how much am I left with? I'm left with half. Well, what happens when I divide that in half? Well, then I'm left with that much of a cookie. The question is, if I keep, well, that's not even a half, but if I keep dividing it in half, will I ever run out of cookie? No, I won't. There will always be a little bit. It may be a tiny bit. It may be a crumb. It may be microscopic, but I will never run out. I will never have 0 cookie. Okay, so what is happening to this equation? And I'm going to draw the line in, but it's getting really big, really fast over this way, but over here it's just getting closer and closer and closer to 0. Okay, we're going to graph one more, and then we're going to come back to this part about an asymptote. On this one, I'm going to show you a different way to get your numbers, because we've talked about this in class. If you press this y equals button, you can type the equation in here. 1 times 0.5 to the power of x, right there. You see the red button? That is the button that you push for your variable. Okay, I'm going to graph it. Oh, and I got mine in the wrong screen, so that means that I am going to have to push zoom, and I want to press 6 for standard. There it is. So there's my graph. That's what it's going to look like. Now, I will never, ever, ever, and your teachers will also never accept you just going, rink. Okay, I want you to hit the correct dots. So how do you get the correct dots? You're going to go second. You see how it's turning the keys red so you know which buttons I'm pushing? And then you're going to push graph, and it takes you to a table of values. Well, I need -3, so I'm going to go up. Okay, -3 is 8. -2 is 4. -1 is 2, and then 1, and then 0.5, 0.125, and 5 is, wait, I can't read that, but I think it's the same as the last one. 313 is what I think that says there. Okay, so, and it rounded there. But hopefully you notice it's just the opposite of the last one. Why is it the opposite? Because instead of having your multiplier be 2, this time your multiplier is 1/2. So it is going the opposite way. Let's go ahead and graph this. -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8 is about right there. -2, 1, 2, 3, 4. -1, 2. 0, 1. And then I know that 1.5 or 1.5 is there, and then it's just going to get smaller. Okay? And that is not on 0, but I'm not very good at making my dots go correctly on here because my board's a little bit off. Anyway, so it does the exact opposite. This time, it's going this way. It's getting close to 0, but it never, ever, ever crosses it. So now let's talk about what is happening there. Now I'm going to just kind of scroll down here. And then let's make this a little bit bigger so we can see those numbers better. Okay, so if you look at these numbers over here, what is happening to them? They are getting, and I know that the E throws you off, but that just means there's more zeros in front of it. It's a small number. These numbers are getting smaller and smaller and smaller, but they're not going to go to 0. Okay, so I'm going to go back to the problem before it. What we have here, and this is our new word here, it's an asymptote. What I like to think of an asymptote is like a fence. Basically, right here at 0, I have this electric fence here, and hopefully you've never touched an electric fence, but what happens when you have an electric fence? You can get really close to it, but if you touch it, it's going to shock you, okay? And you can't cross it because you would get shocked. So what's happening with this exponential equation is it's getting really, 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 really close to this, but it will never, ever, ever touch it or cross it. That is my asymptote. So what we're going to write down is we're going to write down the equation of our asymptote. Well, we just did this a minute ago. What is the equation of that line? We're going to use f of x instead of y. So it's f of x equals, where is that? It is at 0. So your equation will get close to it, but will never, ever cross it. Okay, same thing on this one. Where is my asymptote or my electric fence? Well, it's right here. My equation's getting really close to it. It's coming down. It's skimming. It almost looks like it's touching it because I can't draw very well, but it's not going to touch it. Okay, so what is that equation again? F of x equals 0. Okay, on the next one, and I'm going to take my graph away so I can make this a little bit bigger now. Let's see, can I make that go away? Yes, I can. Now, I can do hard things here. Watch this. Now we're just going to look at this a little bit bigger. You can see once again what are happening to these numbers. These numbers, if you're going up the graph, they're getting smaller. That's what's happening right here. It's getting smaller. It's getting closer to the number 0, but it will never touch it. So where is my asymptote? My asymptote is right here. Okay, even though the equation's on the bottom of the graph, it's down in those bottom 2 quadrants there, it's still getting close to 0. It's never crossing it. So f of x equals 0 is my asymptote once again. Okay, this one changed a little bit. It moved down. Okay, hopefully you're seeing that. Did you notice that all the other asymptotes were f of x equals 0? Okay, so let's look at the table first. If you look at the table, what are happening to these numbers? Which number are they getting close to? Hopefully you notice that, hey, what's this really close to? It's really close to -4. Now let's look at our graph. This is where my asymptote is because that's where it's leveling out. Okay, let's count. 1, 2, 3, 4. Hey, that is -4. So this time my asymptote, or my fence, is at -4. It's getting really close to -4. It will never cross it. Okay, so I'm going to give you a minute, or well, actually I'm not going to give you a minute. I'm just going to ask you to pause the video now. You'll probably want to write down this definition here. An asymptote is an invisible straight line on a graph that curved lines get close to, but they never touch or cross it. So it's like your electric fence. So I'm going to draw in this asymptote, and then we're going to write the equation. Now it says y equals here, so y equals 0. And then underneath it, I'm also going to write f of x equals 0 because hopefully we're used to the fact that f of x equals y. Okay, now I'm going to draw my little electric fence over here. Where is it getting close to and never crossing? Right here. Okay, so y equals 1, 2, 3. Or f of x equals 3. Now, one thing that I want to bring up, in exponential graphs, the ones that we're going to be dealing with this year, the asymptote will always be horizontal, okay? Notice I said this year and right now they will always be horizontal. You will have asymptotes that are vertical next year, but for this year to kind of help you out, it's always going to be that horizontal line. Okay, that is all we're going to talk about with asymptotes for now. Bye.